Tonight, we're going somewhere that doesn't exist anymore, the Mediterranean Basin. Today, this sea feels ancient and permanent, a body of water so familiar it seems like it has always been there. Yet the ground beneath it tells a different story. Layers of solid salt, stacked more than a mile deep in places. Salt like this cannot form beneath a normal ocean. It can only form when the water is gone. Along the edges of this sea, rivers now drift calmly into the horizon, but hidden beneath the sediment, geologists have found something unexpected: ancient canyons carved deep into the bedrock. Some of them cut deeper than the Grand Canyon. Rivers do not carve like that into a full sea. They carve like that when they are falling. Something happened here, something that reshaped Europe, North Africa, and the Middle East all at once. The Atlantic Ocean remained full, but the Mediterranean did not. But how can one of Earth's largest seas simply disappear? What conditions allow evaporation to overpower rivers and oceans combined? How quickly can a stable looking sea collapse once balance is lost? And how close did this disappearance come to becoming permanent? Tonight, we'll follow the clues left behind in salt and stone. We'll ask how one of Earth's largest seas could simply vanish and what brought it back. And we'll walk gently through a world that disappeared long before humans existed to witness it. Before we begin, I'd love to know where you're listening from tonight and what time it is there. I always imagine this calm little community scattered like starlight across the globe, sharing the same story beneath different skies. If these gentle journeys bring you peace, a like or subscribe helps others find their way here too. Now, let your breath slow, let your body settle, and together, let's step softly into the moment when an entire sea vanished. By the time the Mediterranean appears calm again in our story, its surface hides a quiet truth. The sea has never been self sufficient. Even at its most stable, even during long stretches when coastlines barely shifted and life flourished along its edges, it depended on help from beyond its horizon. The Mediterranean sits almost completely enclosed by land. Three continents lean inward around it, narrowing its contact with the rest of the planet's oceans to a few slender passages. These openings are not wide blue gates. They are tight corridors shaped by stone, pressure, and slow tectonic movement. Through them, water must pass constantly, not in dramatic surges, but in steady, patient flow. The climate surrounding this basin adds another layer of quiet strain. Warm air dominates much of the year, drawing moisture upward from the sea's surface. Day after day, sunlight lifts water into the sky faster than clouds can reliably return it. Rivers arrive from distant mountains and interior plains, carrying fresh water and sediment, but their combined contribution is never enough. Rain helps, but only modestly. Left alone, the Mediterranean would steadily shrink. What keeps it alive is the slow inward movement of ocean water from outside. Heavier, saltier Mediterranean water slips outward beneath the surface, while fresher Atlantic water presses inward above it. This exchange is gentle, continuous, and easy to miss. Yet it is the only reason the sea remains a sea at all. This arrangement leaves no room for comfort. The Mediterranean exists in a narrow margin between gain and loss. It survives not because it is strong, but because its balance is carefully maintained. Every shift in climate, every rise or fall of land, every narrowing of its gateways matters more here than in most other oceans. Where the open seas can absorb change, this basin must respond immediately. Over long stretches of Earth's history, this balance has wavered, sometimes only slightly, sometimes enough to leave marks that linger beneath the water. A small reduction in inflow does not simply lower the sea level by a little, It changes the entire equation. As the surface drops, evaporation accelerates. Shallower water warms more easily. Salt becomes more concentrated. The very conditions that cause the loss begin to intensify it. This is the quiet danger of closed seas. They do not fail all at once. They slip. The system leans just far enough that recovery becomes difficult, then harder, then uncertain. Each lost meter of water makes the next loss easier. Each narrowing of a passage reduces the pressure that once pushed life sustaining water inward. The Mediterranean has walked this edge before, not as a single dramatic moment, but as a repeated test of limits. The land around it shifts slowly, lifting and sinking over millions of years. Channels that once flowed freely become shallow, currents weaken, exchange slows. Nothing needs to collapse for the system to begin unraveling. It only needs to hesitate. From above, such changes would have been almost invisible. The sea would still glitter under the sun, waves would still reach familiar shores. But below the surface, the balance would already be tipping, salinity would creep upward, circulation would slow, life adapted to narrow conditions would begin to strain without any sudden sign of disaster. This vulnerability explains why the Mediterranean's history is not one of permanence, but of negotiation. Every era represents a temporary agreement between climate, geography, and motion. As long as water could move in freely enough, the sea endured. When that movement weakened, even slightly, loss gained the advantage. What follows in this story does not begin with violence or catastrophe. It begins with arithmetic, more water leaving than arriving, a deficit repeated day after day, year after year, a sea that could not replace what the sky carried away. In that quiet imbalance, the Mediterranean revealed its true nature, not a fixed feature of the planet, but a system constantly proving it still deserved to exist. The shift did not arrive with noise. There was no single morning when the Mediterranean looked different from the day before. The change began as a quiet imbalance, almost polite in its restraint. Water continued to arrive through the narrow connections beyond the horizon, but it no longer arrived fast enough to replace what the sky was steadily carrying away. Evaporation had always been part of this sea's rhythm. Sunlight warmed the surface, wind brushed across it, and invisible threads of moisture rose into the air. For long ages, that loss was answered by steady inflow. The sea breathed out and was refilled, but as conditions leaned warmer and circulation weakened, the breath outgrew the breath in. Warm climates carry a particular kind of risk for enclosed waters. Heat does not simply remove water, it changes behavior. As the surface warms, evaporation accelerates smoothly at first, then more insistently. Each layer exposed to the sun becomes easier to lift away. The sea grows saltier, and salt changes density, weight, and movement. Currents that once circulated with ease begin to slow, as if thickened. At the same time, falling water subtly reshapes the basin itself. As levels drop, shallow shelves emerge, exposing darker surfaces that absorb even more heat. The remaining water warms faster. The air above it dries. Loss becomes easier, quicker, less reversible. What began as a gentle mismatch turns into a compounding process. This is how destabilization unfolds in closed seas, not through collapse, but through acceleration. Each small decline in water level increases the speed of the next decline. Each delay in refilling magnifies the cost of waiting. The Mediterranean did not simply lose water, it became better at losing water. The inflow that once balanced evaporation now struggled against growing resistance. Narrow passages carried less volume as sea levels fell. Pressure differences weakened. Exchange slowed further. The system that had sustained the sea for millions of years was still operating, but no longer effectively. It was like a heartbeat that could not quite keep pace with the body it served. Salt played its quiet role. As water evaporated, salt remained behind, concentrating slowly at first, then steadily. Denser waters sank, reducing vertical mixing. Nutrients stalled, oxygen movement thinned. The surface and the depths began to separate into different worlds, less connected with each passing season. From the shoreline, nothing dramatic announced this shift. Waves still arrived, tides still moved, but the sea was slipping downward relative to the land, centimeter by centimeter, year by year. Rivers found their mouths stretching farther outward. Estuaries elongated, channels deepened as gravity adjusted to the retreating surface. The critical moment was not a date or an event, it was a threshold, a point where evaporation no longer merely exceeded refilling, but ensured that refilling could not catch up. Once crossed, the system stopped correcting itself. Loss created conditions that encouraged further loss. This is what scientists describe as runaway behavior. Though it unfolds quietly, there is no sprint, only momentum. The sea enters a state where stopping the decline would require more water than the pathways could deliver. Even if conditions briefly improved, the system's new geometry worked against recovery. The Mediterranean had crossed that line before in smaller ways, brushing against instability and retreating back into balance. This time, the retreat was slower, more hesitant, and less forgiving. Warmth lingered, gateways narrowed, exchange weakened just enough to let arithmetic take control. The water level continued its gentle descent. Evaporation continued its patient work. Each season carried away more than arrived. Each year deepened the deficit. The sea was no longer keeping up with itself. What followed was not sudden disappearance, but the beginning of inevitability. A sea shaped by delicate balance had slipped into a state where balance no longer existed, and in that quiet transition, the Mediterranean began to fall behind the sky. The change that followed was no longer hidden beneath the surface. As the Mediterranean continued to lose water, the sea began to reveal parts of itself that had not seen air for millions of years. The retreat was slow enough to feel unreal, yet steady enough to redraw the map of an entire region. Continental shelves emerged first. These wide, shallow margins that once lay quietly beneath the waves began to dry under the sun. What had been seabed became coastline, then land. The sea did not pull back evenly. In some places it lingered, held by local depth or shadow. In others, it slipped away quickly, exposing vast stretches of pale sediment and cracked salt-stained ground. As water levels dropped further, the shoreline moved outward again and again. The familiar edge of the sea migrated across what had once been open water, retreating distances that would have taken generations to walk. Bays lengthened into plains. Islands merged with the mainland. Peninsulas stretched farther into empty space, no longer surrounded by water on all sides. The Mediterranean was not simply shrinking, it was falling below its former self, leaving behind a layered memory of where it had been. Each new shoreline marked a previous pause in the descent. Each abandoned terrace recorded a moment when loss briefly slowed before continuing again. Along these shifting edges, ecosystems unraveled quietly. Reefs that had grown slowly in stable water found themselves stranded in air too harsh to tolerate. Their intricate structures dried and crumbled, turning living architecture into brittle stone. Creatures that depended on them vanished with little trace, leaving gaps that would not be filled again in the same way. Shallow seas that once supported dense webs of life became hostile flats. Algae bloomed briefly in concentrated pools, then collapsed as salinity climbed. Fish retreated into deeper basins or disappeared entirely. What remained was a narrowing band of survivable water squeezed between rising salt and falling levels. Ports, in the broad geological sense, ceased to exist. Natural harbors that had sheltered currents and concentrated nutrients were left inland, disconnected from the sea they once served. River mouths shifted outward, their channels cutting deeper as gravity adjusted to the lowering surface. Sediment that once spread gently across deltas now rushed downward, carving paths instead of building them. The exposed land was harsh. Without the moderating influence of water, temperatures swung sharply. Daytime heat baked the surface, while nights cooled it rapidly. Winds swept across open expanses, lifting fine grains and carrying salt far inland. The air itself grew heavier with mineral dust, changing how light scattered across the basin. Life did not end everywhere at once. It withdrew, step by step, following the shrinking boundary where water still behaved like a sea. But each retreat compressed ecosystems into smaller spaces, intensifying competition and stress. Species adapted to narrow conditions found themselves pressed against limits they could not cross. What had once been a broad, connected marine world fractured into zones of survival separated by distance and chemistry. Communication between populations weakened, migration paths vanished, reproduction faltered as habitats fragmented. Loss did not arrive with violence, but with narrowing choice. From a distance in time, this transformation can seem inevitable, but within the moment it unfolded through ordinary processes. Sunlight, wind, gravity, and salt did their quiet work. No single force dominated. Instead, familiar elements combined in unfamiliar proportions. The Mediterranean now occupied a lower place than it once had, not just in elevation, but in function. It could no longer support the systems that had thrived when water was abundant and exchange was steady. It had become a basin in retreat, shaped less by circulation and more by exposure. As shelves widened and coastlines slipped outward, the sea carried its remaining life deeper, concentrating it into shrinking refuges. Above those waters, the newly revealed land bore silent witness to a change that unfolded without sound, without fire, and without haste. The sea had begun to leave itself behind. As the Mediterranean fell, the rivers noticed first. They did not hesitate or adjust slowly. They responded with speed, guided by a force they could not ignore. Gravity had changed its terms. For millions of years, rivers flowing into the sea had ended their journeys gently. They slowed as they approached the coast, spreading sediment into deltas, fanning outward, losing energy as the water met an unchanging surface. Their mouths were stable, their slopes were shallow. The work they did was patient and wide. But when the sea level dropped, the end point of every river moved downward with it. What had once been a short, quiet descent became a long, steep fall. Suddenly, rivers had somewhere to go. As the Mediterranean surface retreated, the base level that controlled erosion fell away. Rivers stretched to reach it. Channels deepened. Flow accelerated. Water that once wandered now rushed. Each drop carried more force than before, pulled by a steeper path carved into the land itself. This transformation happened quickly by geological standards. Rivers began cutting downward rather than outward. Sediment that once settled now scoured. Beds hardened by time gave way under sustained pressure. The landscape responded not with collapse, but with incision. Canyons formed where none had existed. Valleys deepened far beyond what rain alone could explain. Rivers sliced into bedrock with a persistence that reshaped entire regions. In places, the cutting reached depths greater than any modern river valley, descending far below what the present sea level would ever allow. These were not slow scars etched over tens of millions of years. They were sudden, decisive cuts made during a narrow window of imbalance. The rivers worked with urgency, driven by the need to reconnect with a sea that was no longer where it used to be. As the sea continued to fall, the rivers followed it downward, step by step. Each pause in the sea's retreat became a temporary resting place for erosion. Each renewed drop sent the rivers carving again. The result was a stair-stepped landscape of channels and terraces, each marking a moment in the descent. The scale of this carving was immense. Entire drainage systems reorganized themselves, tributaries extended farther inland, watersheds shifted. What had once been separate flows merged or diverged under the new geometry of the land. From above, the basin would have looked transformed. Long, dark corridors cut across pale sediment. Winding channels traced paths far below the surrounding terrain. These were not the marks of floods or storms, but of persistence under altered rules. When the Mediterranean eventually refilled, these rivers lost their newfound power. The base level rose again, slopes softened, energy dissipated. The cutting stopped as abruptly as it had begun. Water returned to spreading rather than slicing. But the canyons remained. As the sea reclaimed the basin, it flooded the deep valleys the rivers had carved. Water poured into them, filling their depths, burying their walls beneath new layers of sediment. What had once been open-air passages became submerged corridors hidden below the surface. Today, these features still exist. They lie beneath modern seas, invisible from shore, preserved in seismic echoes and drilling cores. Beneath calm water and familiar coastlines, ancient river valleys stretched downward, recording a time when rivers ran far below the level they occupy now. These buried canyons tell a precise story. They speak of rapid change, of a sea that fell fast enough to give rivers extraordinary reach. They reveal how closely land and water are linked, how a shift in one rewrites the other almost instantly. The rivers did not cause the Mediterranean's decline, but they recorded it with clarity. Their paths remain as quiet proof that the sea once stood far lower, long enough and deep enough to reshape the continent's veins. Even now, as waves move gently above them, these hidden channels hold the memory of a moment when gravity briefly ruled unchecked, and rivers carved downward with a force they would never again possess. As the retreat continued, the Mediterranean ceased to behave as a single body of water. What had once been a connected sea began to fragment, not through violence, but through separation. Depths that once linked distant regions thinned and vanished. Ridges rose into barriers. Channels closed. Water that could no longer flow freely became trapped where it stood. The basin broke apart quietly. Instead of one continuous sea, there were now several, each responding differently to the same loss. Deeper pockets held on longer, cradling the last remnants of open water. Shallower regions crossed a threshold first, slipping from sea to lake, from lake to something stranger. These isolated basins no longer shared balance. Each became its own experiment, shaped by local depth, heat, and chemistry. Some shrank slowly, concentrating salt with each passing season. Others collapsed faster, their water turning dense and heavy, sinking under its own weight. Open circulation ended. Without steady exchange, water stopped renewing itself. Evaporation pulled away the lightest elements, leaving minerals behind. The remaining liquid thickened, darkened, and changed character. It no longer moved like a sea. It rested, it pooled, it waited. Salt lakes formed where waves once traveled freely. Their surfaces were smooth and reflective, broken only by slow crystallization along the edges. As water continued to leave, salt precipitated out, settling onto the basin floor in quiet layers. Grain by grain, the landscape recorded the imbalance. These lakes were not gentle places. Salinity climbed beyond levels most marine life could tolerate. Oxygen thinned, chemical gradients sharpened. Each basin developed its own internal structure, with dense, heavy layers lying beneath lighter ones, resisting mixing. The water became hostile in subtle ways. It burned more than it nourished. Organisms adapted to narrow ranges found no refuge here. Some lingered briefly in transitional zones, but most vanished as conditions drifted beyond recovery. Life did not flee in panic, it faded where it stood. As the chemistry intensified, new processes took hold. Minerals crystallized directly from solution. Gypsum and halite formed in repeating sequences, each layer marking a pulse of loss. These deposits accumulated steadily, building thickness that spoke not of storms or floods, but of long, relentless drying. The air above these basins carried a different weight. Evaporation cooled the surface slightly, but left the surrounding land hotter and drier. Winds swept across exposed flats, lifting salt dust into the atmosphere. The horizon shimmered under heat, blurring water and land into a single pale field. What had once been blue space became white and amber. Reflections grew harsh. The smell of minerals replaced the scent of open sea. The Mediterranean's heart had turned inward, breaking its connection with the rhythms that once sustained it. Each basin told a different version of the same story. Some retained water long enough to build thick chemical archives. Others dried more completely, leaving crusted floors cracked into polygons. Together, they formed a mosaic of extremes, spread across what had once been a unified marine world. This fragmentation mattered deeply. Without connection, recovery became harder. Even if water returned to one basin, it could not easily reach another. The sea's former ability to redistribute heat, salt, and life was gone. Balance, once lost, could not simply be restored by chance. The Mediterranean was no longer failing as a whole, it was failing in pieces. Yet even in this broken state, the process remained quiet. There were no waves to announce collapse, no currents to carry sound. Change arrived through chemistry and patience. The sea was dismantling itself layer by layer. In the depths of these isolated basins, the planet wrote one of its clearest records of imbalance. Salt accumulated not because of catastrophe, but because nothing stopped it from doing so. Water left. Minerals stayed. Time did the rest. By the end of this phase, the Mediterranean was no longer recognizable as a sea. It had become a scattered collection of extreme environments, each shaped by loss, each preserving evidence of how separation turned vulnerability into transformation. By the time the Mediterranean had broken into isolated basins, the landscape was no longer defined by water alone. What remained began to leave a record, one written not in waves or currents, but in minerals settling quietly onto the basin floors. This record would later challenge everything scientists thought they understood about how salt forms in the ocean. Under ordinary conditions, salt behaves predictably. In the open seas, minerals arrive dissolved, carried by rivers and deep circulation. They remain suspended, mixed constantly by currents and storms. Even over immense spans of time, they do not pile up into massive layers. The ocean is too alive, too connected, too well stirred for that to happen. But beneath the Mediterranean, something very different appeared. As evaporation continued and circulation remained broken, salt no longer stayed dissolved. It crystallized directly from shrinking bodies of water. Each pulse of evaporation left behind a thin skin of minerals. Each brief return of water dissolved some, only to deposit it again as conditions shifted. Over time, these skins stacked one atop another. What geologists later found were not scattered crystals or thin crusts. They found enormous sequences of solid salt layered like pages in a book. These deposits extended across vast areas of the basin, lying beneath modern sediments, undisturbed and unmistakable. The thickness of these layers was what made them impossible to ignore. In some places, the salt measured not in meters, but in hundreds of meters. In others, it reached depths comparable to the height of mountain ranges laid on their side. Such accumulations could not be explained by normal marine processes. No stable sea, no matter how long it endured, could quietly produce salt on this scale. These layers told a story of repetition. Water entered, evaporated, and left its minerals behind, again and again. Each cycle built upon the last. The basin did not refill fully between episodes. It hovered near dryness, allowing salt to accumulate rather than disperse. For scientists, this was deeply unsettling. Salt of this thickness implied that the Mediterranean had lost and regained water multiple times, or had remained near empty long enough for evaporation to do extraordinary work. Either scenario required conditions far outside what was once considered plausible for a sea connected, even weakly, to the global ocean. The salt itself held clues to its environment. Some layers formed in relatively shallow water, marked by fine crystals and delicate structures. Others suggested deeper pools, where heavier minerals settled differently. Together, they traced fluctuations in water level and chemistry with remarkable precision. Buried within these deposits were interruptions, thin seams of clay or organic material. These were moments when water briefly returned, bringing sediment from rivers or dust from distant lands. Then evaporation resumed, sealing those moments beneath new layers of salt. The scale of accumulation revealed the duration of imbalance. This was not a brief anomaly. It was a sustained period when the Mediterranean behaved less like a sea and more like a series of evaporating pans, each responding to the same relentless arithmetic of loss. When drilling corps first recovered these sequences, they rewrote expectations. The Mediterranean, long viewed as a stable and enduring feature, had once been capable of producing conditions more extreme than most deserts, and it had done so quietly, without fire or ice. The salt also preserved absence. Where life once thrived, there were now mineral layers devoid of biological markers. The water had become too harsh to support even resilient organisms. Salt recorded not just evaporation, but exclusion. Today, these layers remain hidden beneath the seafloor, compressed by younger sediments, protected from erosion by the very water that returned later. They rest in darkness, holding a memory of a sea that nearly vanished. Their existence stands as one of the strongest pieces of evidence that the Mediterranean crossed into a state far beyond ordinary drying. It did not simply lower, it transformed into an environment capable of building mineral monuments, layer upon layer, in silence. The salt should not exist under normal conditions, yet it does, vast and undeniable, preserved beneath the calm surface of a modern sea that gives no hint of how close it once came to becoming something else entirely. As salt accumulated and water withdrew, life faced a change it could not outrun. The Mediterranean did not become empty all at once. It became difficult, then hostile, then selective. Survival narrowed quietly, guided by chemistry rather than force. Salinity rose with each cycle of evaporation. What remained of the water grew heavier, denser, and less forgiving. Organisms that had evolved for stable marine conditions now lived in fluid that pulled moisture from their cells, disrupted their chemistry, and strained the most basic processes of life. Breathing, feeding, and reproduction all became harder in ways that left no visible scars, only absence. The first to disappear were those least able to adjust quickly. Delicate plankton that drifted freely through the water depended on narrow chemical ranges. As salt concentrations crept upward, their populations thinned. Blooms that once fed entire food webs faded without ceremony. With them went the foundation of the ecosystem. Creatures tied to shallow waters followed soon after. Many fish relied on predictable salinity to regulate their internal balance. As conditions shifted beyond tolerance, they retreated toward deeper basins where water remained slightly less extreme. Those that could not migrate fast enough or reproduce quickly enough vanished where they lived. Shell-forming organisms faced a different struggle. Changes in chemistry altered how minerals behaved in water, making it harder to build and maintain protective structures. Growth slowed. Fragile shells dissolved faster than they could be repaired. Reefs that had already been stranded by falling water now failed chemically as well. Life that survived longest tended to be small, flexible, and patient. Some microorganisms endured higher salinity by slowing their metabolism, waiting through harsh periods rather than thriving within them. Others adapted briefly, altering internal chemistry just enough to persist, but these were exceptions, not solutions. As species disappeared, ecosystems did not collapse with sound or spectacle. They thinned, connections weakened, predator and prey relationships unraveled as one vanished before the other. Food chains shortened, then broke entirely. The water grew quieter, not from calm, but from absence. Without constant movement and mixing, oxygen became unevenly distributed. Some layers retained enough to support limited life. Others turned stagnant, hostile to anything that required steady exchange. The separation of layers created invisible barriers within the water itself, isolating what little life remained. The loss of biodiversity did not arrive evenly. Each basin followed its own path, depending on depth, temperature, and chemical balance. Some retained marginal ecosystems longer, harboring pockets of survival that flickered for generations. Others crossed thresholds quickly, becoming nearly lifeless pools dominated by mineral processes rather than biological ones. This was a siege without attackers. No single factor could be blamed. Salinity rose, oxygen thinned, nutrients stalled. Each stress compounded the others, tightening conditions until survival became improbable rather than impossible. Life did not flee, it failed quietly. On land, newly exposed surfaces offered little refuge. Salt-laden winds and extreme heat discouraged colonization. Plants struggled to take hold. The basin floor remained largely barren, reflecting sunlight and reinforcing the conditions that had stripped life from the water. The Mediterranean's collapse was not marked by extinction on a global scale. It was regional, contained, and therefore easy to overlook in deep time. Yet within the basin, the impact was profound. Entire communities that had existed for millions of years were erased, not by sudden catastrophe, but by the steady narrowing of what it meant to survive. Fossil records from this interval show gaps rather than endings. Species disappear from layers and reappear much later, often changed. Some never return at all. The silence between these records speaks to a time when the sea could no longer support the diversity it once held. This chemical siege left no monuments above the surface. Its evidence lies buried in salt and stone, in missing shells, in altered sediments. It records a lesson repeated throughout Earth's history, that life depends not only on water, but on balance. As the Mediterranean continued its transformation, it carried fewer living witnesses with it. What remained was a sea increasingly shaped by chemistry and physics alone, its biological voice fading into the background of a changing world. As the water withdrew and life thinned, the Mediterranean revealed a landscape that had been hidden for longer than any human lineage has existed. The basin floor, once sealed beneath kilometers of water, lay exposed to the open sky. What emerged was not a familiar land, but a surface shaped by absence. The newly uncovered ground stretched outward in vast, pale expanses. Former seabed, rich with salts and fine sediments, reflected sunlight with a dull, blinding glare. Without water to soften temperature or movement, the land responded directly to the sun and wind. Heat built quickly during the day, then fell away just as sharply when night arrived. The ground cracked as moisture fled, forming geometric patterns that shifted with each passing season. This was not soil that welcomed roots. Salt lay close to the surface, crusting into brittle sheets that broke under their own weight. In places, crystals formed delicate towers and ridges, growing silently as evaporation continued. Elsewhere, the surface hardened into plates that rang faintly under the pressure of wind-driven sand. The air above the basin carried its own signature. Warm, dry currents swept across the exposed floor, lifting fine particles into suspension. Salt dust traveled far, carried inland and outward, settling on distant slopes and altering regions far beyond the basin itself. Visibility often blurred under this haze, the horizon dissolving into light and heat. Without the sea's moderating influence, temperatures climbed to extremes. Sunlight poured down uninterrupted, baking the surface until it shimmered. The basin became a heat trap, its low elevation holding warmth long after surrounding highlands had cooled. Nights brought little relief. Dry air released heat quickly, but the land retained enough to remain harsh and unwelcoming. Wind shaped the environment with persistence rather than violence. It scoured the surface, redistributing salt and sediment into low dunes and streaked patterns that stretched for kilometers. Every exposed feature was slowly refined, edges softened or sharpened depending on grain and resistance. The basin floor was never still, yet nothing truly moved forward. Water, when it appeared, arrived briefly and without comfort. Rare rainfall pooled in shallow depressions, dissolving surface salts and creating temporary brines. These pools evaporated quickly, leaving behind new mineral patterns that overprinted the old. Each cycle added complexity, but not habitability. To stand in this environment would have been to exist without shelter. There were no forests to soften wind, no rivers to cool the air, no stable ground to anchor life. The scale alone would have overwhelmed any familiar sense of place. Distances stretched uninterrupted, broken only by subtle changes in texture or color. This was one of the harshest environments the planet produced without fire or ice. It rivaled the great deserts in severity, yet differed in origin. Its hostility came not from lack of water alone, but from its history. The basin floor was not shaped for exposure. It was a place meant to remain submerged, suddenly subjected to conditions it could not moderate. The silence would have been profound. Without waves, without widespread life, without the sounds of flowing water, the basin held a quiet unlike most landscapes. Wind and occasional mineral shifts provided the only movement. The air itself felt heavy with stillness. For Earth, this landscape was not an error, but a phase. It emerged because balance failed, and it persisted because recovery had not yet arrived. The basin recorded this interval in its surface, layer by layer, pattern by pattern. Long after water returned and concealed this world once more, traces of it remained. Mineral distributions, buried surfaces, and altered sediments preserved the memory of exposure. Beneath the modern sea, the imprint of this extreme landscape still exists, flattened and hidden, but intact. This was a place humans were never meant to see, not because it was forbidden, but because it belonged to a different chapter of the planet's story. It existed quietly, briefly, and completely on its own terms, waiting for the moment when water would reclaim it and return the basin to a state that feels more familiar today. By the time the Mediterranean reached its most reduced state, the planet had entered a narrow corridor where outcomes diverged sharply. What existed then was not merely a damaged sea, but a system balanced on the edge between recovery and permanence. The difference between those futures was smaller than it appears in hindsight. At its lowest extent, the Mediterranean had lost much of what once allowed it to function as a sea. Exchange was weak, basins were isolated, chemistry dominated, biology and vast stretches of the former seafloor lay exposed to the sky. Yet even in this diminished form, a fragile connection to the wider ocean still existed. That connection was thin, but it mattered more than anything else. Had conditions shifted only slightly further, the remaining pathways for water would have closed completely. Tectonic movement could have lifted land by a modest amount. Sea level elsewhere could have dropped just a little more. Climate patterns could have tilted warmer or drier for a longer span. Any of these changes alone, small on a planetary scale, might have been enough to sever renewal entirely. Once fully cut off, evaporation would have finished its work. Residual water would have vanished. Salt would have spread across the basin floor without interruption. The Mediterranean would have ceased to be a sea in any meaningful sense, becoming a permanent salt desert far below global sea level. What made this moment so precarious was not the drama of collapse, but the simplicity of the math. Water leaving faster than water arriving does not require catastrophe to continue. It only requires persistence. And persistence is something Earth supplies easily. Geological systems often behave this way. They move slowly, then suddenly refuse to reverse. As long as certain thresholds remain unbroken, balance can wobble and recover. Once crossed, the same forces push only in one direction. These thresholds are not visible. They announce themselves only after they have been passed. In the case of the Mediterranean, the threshold lay in connection. As long as even a narrow exchange with the Atlantic remained, recovery stayed possible. Water could return, chemistry could soften, life could recolonize. Remove that exchange, and the system would have locked itself into dryness. This is what scientists describe, quietly, as a point of no return, not a single moment, but a zone where reversal becomes increasingly unlikely. The closer a system drifts toward it, the more energy is required to pull it back. Eventually, no realistic change can restore what was lost. Earth has crossed such points before. Entire seas have vanished. Mountain ranges have altered climates permanently. Ice sheets have reshaped circulation in ways that persist long after they retreat. The Mediterranean came close to joining that list, not as an exception, but as part of a pattern. What spared it was timing. A combination of tectonic movement and ocean level allowed water to return before the final thresholds were crossed. The balance tipped back just enough, soon enough, to prevent permanence. Recovery did not need to be gentle or gradual. It only needed to begin. This near miss reshapes how stability is understood. The Mediterranean looked enduring for millions of years before this event, and it looks enduring now. Yet its history reveals that endurance can rest on margins thinner than coastlines suggest. What appears permanent may only be paused between tests. The lesson preserved beneath the sea is not one of disaster, narrowly avoided by chance alone, but of systems constantly negotiating their limits. Earth does not protect features because they are familiar. It allows them to persist only while conditions permit. The Mediterranean survived this episode, but it did so by remaining just within reach of recovery. Had the balance tipped a fraction further, the basin would have entered a state no flood could undo. In that sense, this was one of the planet's most extreme near misses, not because destruction loomed suddenly, but because permanence waited quietly on the other side of a very small change. As the Mediterranean hovered near its point of no return, everything depended on a place that appeared insignificant on the scale of continents. At the western edge of the basin, where Africa and Europe leaned toward one another, a narrow opening controlled the fate of an entire sea. This was the invisible gate at Gibraltar. Through this passage, the Mediterranean had long received the water it could not replace on its own. The flow was steady rather than dramatic, guided by differences in density and height between basins. To the eye, it would have looked like ordinary water movement. To the system, it was life support. The gate mattered because it was narrow, not metaphorically narrow, but physically constrained by rock, shaped through millions of years of slow collision and separation. Continents do not meet cleanly. They grind, buckle, rise, and sink in uneven ways. Gibraltar sat at one of these restless seams. As Africa pressed northward and Europe resisted, the land beneath the passage shifted. Subtle uplifts reduced depth, sediments accumulated, channels narrowed. Each small change altered how easily water could pass. Flow that had once been sufficient became restricted, then unreliable. Tectonics do not need to close a passage entirely to change its impact. Reducing depth by a modest amount can dramatically limit volume. Slowing inflow by a fraction can tip balance when evaporation remains constant. At Gibraltar, these small adjustments mattered enormously. The Mediterranean depended on a delicate difference in levels. The Atlantic stood slightly higher, pushing water inward across the threshold. As the Mediterranean fell, this difference increased, but only as long as a pathway remained open. Narrow that pathway too much, and pressure alone could not compensate. The gate became a choke point, not through sudden blockage, but through gradual interference. Land rose millimeter by millimeter, sediments settled, currents weakened. What had once been a reliable exchange became intermittent. This fragility is written into the geography. Gibraltar is not a wide channel, like those that connect major oceans. It is a corridor that can be altered by the smallest of geological gestures. A slight uplift, a shift in fault movement, a change in sediment delivery, and the entire system responds. During the Mediterranean's decline, this gate flickered between function and failure. At times, enough water passed to slow the loss. At others, inflow lagged behind evaporation, allowing decline to accelerate. The basin's fate rose and fell with this variability. What makes this moment remarkable is how little control the Mediterranean itself had over the outcome. Its internal processes mattered, but they were secondary. The real decision lay at the gate. As long as Gibraltar remained open enough, recovery stayed possible. If it closed fully, permanence followed. This relationship reveals a broader truth about Earth systems. Stability often depends on narrow links. Remove or weaken them, and entire regions shift into new states. These links are easy to overlook because they are small compared to what they influence. The invisible gate was not designed to fail or endure. It simply responded to forces acting upon it. Tectonics moved land as they always had. Sediments followed gravity. Water obeyed physics. The outcome was determined by timing and proportion. When conditions finally favored renewed connection, it was not because Gibraltar widened dramatically, but because it remained open just enough. That small allowance changed everything. It allowed water to return, slowly at first, then with growing force. The Mediterranean's near disappearance was not prevented by strength or resilience within the basin. It was prevented by the survival of a single fragile passage at the edge of the sea. Even now, this gate remains narrow, shaped by the same forces that once threatened to close it. Its presence is a reminder that vast systems can depend on small places, and that the fate of oceans can rest on corridors measured in kilometers rather than continents. As the story moves forward, the importance of this gate becomes clearer, not as a dramatic barrier, but as a quiet hinge upon which the Mediterranean's future turned. As the narrow gate at Gibraltar continued to waver, a quiet imbalance grew on either side of it. The Atlantic and the Mediterranean no longer shared the same level or rhythm. They became two neighboring systems holding different amounts of water, separated by a fragile threshold that was never meant to bear such responsibility. To the west, the Atlantic remained full and patient. Its vastness absorbed seasonal shifts without visible change. Tides rose and fell, storms passed, and deep currents continued their long circuits. The ocean's surface stayed high, steady, and indifferent to the struggle unfolding just beyond its edge. To the east, the Mediterranean sat lower, thinner, and increasingly strained. Evaporation continued its steady work, lifting water into warm air and leaving salt behind. Each loss pulled the surface down a little more. The difference in height between the two seas grew slowly, but it grew relentlessly. This difference mattered. Water moves not only by volume, but by pressure. The higher Atlantic pressed inward, seeking equilibrium. The lower Mediterranean pulled at that pressure like a quiet vacuum. Between them, Gibraltar became the only place where imbalance could resolve itself. As the gap widened, stress accumulated invisibly. The land beneath the gate bore the load of this difference. Rock that had once guided gentle exchange now resisted increasing force. Currents accelerated where space allowed, scouring channels and reshaping the seabed grain by grain. The pressure did not announce itself with noise. It built like weight on a hinge. Each moment of restricted flow increased the strain on the next. The system was not broken, but it was no longer relaxed. Everything depended on how long the barrier could endure. Within the Mediterranean, the lowered water level intensified internal stress as well. Denser, saltier water settled into deeper pockets. Circulation slowed further. The remaining basins became heavier, pressing downward on the crust below. Though subtle, this added weight contributed to the region's tectonic tension. On the Atlantic side, water piled slightly higher near the threshold, not enough to notice from afar, but enough to matter at the scale of currents. The ocean leaned toward the opening, its mass constantly testing the resistance of land. This was a system under strain not because forces were extreme, but because they were persistent. No single moment demanded release. Instead, every moment added a little more pressure to the same narrow point. Geological systems respond poorly to long-held imbalance. Rock can flex, but only so much. Sediment can accumulate, but only until it destabilizes. Eventually, resistance gives way, not gradually, but decisively. The Mediterranean and the Atlantic were no longer simply neighbors. They were participants in a slow negotiation, each exerting influence through height, density, and time. The gate between them felt every subtle shift. From within the basin, the effects remained indirect. Water levels continued to fall or stabilize briefly, then fall again. Chemistry continued to intensify. Life, where it remained, adapted or vanished. Yet beneath all of this, the larger system waited. Stress does not need awareness to be effective. It accumulates whether or not conditions appear calm. By the time signs of release become visible, the outcome is often already determined. The difference in levels reached a point where holding back the Atlantic required continuous resistance. The gate could not simply remain as it was. It would either open more fully or close beyond recovery. Balance would not tolerate indecision forever. In this state, the Mediterranean hovered between futures. One path led to isolation made permanent. The other led to reconnection on a scale the basin had not experienced before. Which path emerged depended not on intention, but on physics responding to strain. As pressure continued to build on both sides, the system approached a moment when quiet accumulation would give way to motion. The land, the water, and the forces between them prepared, without sound, for whatever release would finally arrive. The first hints of change did not arrive as a reversal, but as hesitation. After long ages of loss and strain, the Mediterranean began to receive water again, not enough to heal it, but enough to disturb the stillness that had settled across the basin. These early refilling events were weak, uneven, and uncertain, like shallow breaths taken after a long silence. Water found its way back through the fragile western gate in modest amounts. The flow was not steady. It pulsed. At times it slowed to almost nothing, then resumed briefly before thinning again. Each pulse carried Atlantic water into the lowest parts of the basin, spreading thin sheets across salt-hardened floors. These returns did not erase what had formed. Salt crusts dissolved at the surface, but remained intact below. Brine pools softened slightly, then concentrated again as evaporation continued. The system shifted back and forth, unable to decide which state it belonged to. Temporary reconnections followed this same pattern. Channels that had nearly closed reopened just enough to allow passage, then narrowed again. Water crossed thresholds it had not reached in generations, filling basins that had been isolated for long stretches of time. For a while, some regions resembled shallow seas once more. In these moments, circulation stirred faintly. Layers mixed just enough to redistribute heat and chemistry. Oxygen returned to pockets that had been stagnant. Minerals dissolved back into solution, softening the extremes that had dominated before. Life responded cautiously. Microorganisms spread into newly diluted waters, multiplying quickly where conditions allowed. Algae appeared in thin veils, tinting the surface briefly before retreating again. These were not full recoveries, but signs that the system still remembered how to function. Rivers adjusted once more. Their deep channels carried water outward, feeding the returning sea. Sediment moved differently now, filling some cuts while deepening others. The land recorded each change, adding new layers atop the old. Yet these recoveries did not last. Each period of refilling was followed by renewed loss. Evaporation remained strong. Inflow weakened again as passages narrowed. Water levels stabilized briefly, then fell. The Mediterranean entered a cycle of hope and reversal, a rhythm that left no lasting resolution. These false recoveries are preserved in the geological record as alternating layers. Thin marine sediments appear between thick deposits of salt and evaporated minerals. Each marine layer marks a moment when the sea almost returned. Each salt layer marks the retreat that followed. From a distance in time, these fluctuations can appear chaotic, but they followed a simple logic. The system had not yet crossed fully back into stability. It hovered near the boundary, sensitive to every small change in climate, sea level, and tectonic motion. What made these moments deceptive was their familiarity. Shallow waters, gentle circulation, and brief biological activity resembled the early stages of recovery, yet lacked the strength to endure. Without sustained connection, the Mediterranean could not rebuild its balance. These temporary states mattered deeply. They prevented complete desiccation, they softened chemical extremes, they kept pathways open, however weakly, between basins that might otherwise have remained isolated. In doing so, they preserved the possibility of true return, but they also delayed it. Each partial refill reduced pressure differences slightly, easing strain on the gate without fully opening it. The system lingered in compromise, neither collapsing entirely nor recovering fully. This in between state shaped what came next. The basin learned how to accept water again, carving channels and redistributing sediments that would later guide larger flows. The land adjusted to the idea of return, even as it endured repeated disappointment. These early refilling events were not failures, they were rehearsals. They tested pathways, revealed weaknesses, and prepared the basin for a change that would eventually arrive with far greater force. For now, the Mediterranean existed in a fragile rhythm of advance and retreat. Water came back, then slipped away. Life flickered, then faded. The sea stood at the threshold of renewal, not yet crossing it, but no longer entirely beyond reach. The end did not come as a surprise to the planet. By the time the barrier failed, the system had been preparing for it through countless small adjustments. Pressure had been building, pathways had been tested, and the difference between the Atlantic and the Mediterranean had grown too large to be held back any longer. Failure at the scale of an ocean does not resemble collapse in the human sense. There is no shattering sound, no single crack that announces the change. Instead, resistance gives way. The land that had limited flow yields just enough, and water responds instantly. At Gibraltar, the fragile choke point could no longer contain the imbalance pressing against it. The Atlantic stood higher, heavier, and persistent. The Mediterranean lay far below, open and waiting. When the remaining barrier thinned past a critical point, holding back the ocean ceased to be possible. Water did not hesitate. It surged toward the lower basin, drawn by gravity and pressure that had been accumulating silently for ages. What had once been a controlled exchange became something entirely different. Flow accelerated beyond anything the region had experienced before. This was not a river breaking its banks, it was an ocean reclaiming a basin. The inevitability of this moment lay in simple physics. As long as a height difference existed and a pathway remained, water would seek balance. The longer resistance delayed that process, the more force accumulated behind it. Once the barrier weakened enough, release was guaranteed. The Mediterranean had already done the work of preparing its own refilling. Deep basins waited far below global sea level. Channels carved by ancient rivers pointed inward. The landscape had been shaped by absence, creating a vast container ready to be filled. When the barrier failed, balance collapsed in a single direction. There was no gradual adjustment. The Atlantic poured in faster than evaporation could remove water, faster than sediments could settle, faster than chemistry could resist change. The returning water did not arrive gently. It fell, dropped, and rushed downward into the basin, accelerating as it descended. The energy involved dwarfed anything produced by modern rivers or storms. This was gravity acting on an ocean. As water rushed in, it began erasing the extremes that had defined the Mediterranean's near disappearance. Salt crusts dissolved rapidly, chemical gradients blurred, Isolated basins reconnected under a rising surface. What had been fragmented started to merge again. Yet even this was not chaos. It was reorganization. Water followed paths already carved. The basin guided the flow, directing it into the deepest regions first, then outward as levels rose. The same forces that had once drained the sea now worked in reverse. This moment marked a clear transition. The Mediterranean crossed back over the threshold it had approached so closely before. The system moved from loss driven by evaporation to gain driven by inflow. The arithmetic reversed. What made this failure so powerful was not violence alone, but scale. Entire regions experienced change simultaneously. Coastlines shifted inward rapidly. Exposed basin floors vanished beneath advancing water. Environments that had endured extremes were submerged again. The land did not resist this return. It accepted it, reshaped by the weight and movement of water. Sediments were lifted, redistributed, and buried. Channels deepened further under the force of incoming flow. From the perspective of deep time, this moment stands out not because it was rare, but because it was decisive. Many systems hover near imbalance and retreat. Few cross so fully from near extinction back into recovery. The barrier's failure did not erase the Mediterranean's past. It sealed it beneath layers of new sediment and water. Evidence of what came before remained, hidden and preserved, but no longer shaping the surface. This was the moment when uncertainty ended. The Mediterranean was no longer negotiating its survival. It had been reclaimed by the ocean that once fed it. The collapse of balance was complete, and in that collapse, the conditions for renewal were finally set. What followed the barrier's failure was not a return to normal flow, but the release of an imbalance that had been held back for far too long. The Atlantic did not trickle into the Mediterranean. It fell. Water poured into a basin that had been carved, dried, and lowered far below the level of the global ocean. The difference in height was immense. As the first volumes crossed the threshold, gravity took command. The flow accelerated immediately, pulled downward by a drop measured not in meters, but in kilometers. This was not a flood spreading outward across land. It was a descent. Water plunged into the Mediterranean basin with relentless force, racing along channels that had once been narrow exchanges and now became pathways for an ocean. The sound, if it could be heard, would not have resembled waves or rain, but continuous thunder carried across stone. The scale of this movement exceeded anything found on Earth today. Modern rivers, even at their strongest, move water across landscapes already shaped by flowing currents. Here, water was reshaping the landscape as it arrived. The basin floor offered no resistance. It accepted impact, erosion, and burial all at once. As the inflow accelerated, it stripped sediment from every surface it touched. Loose material vanished first, lifted and carried into the depths. Harder layers followed, ground down by turbulence and pressure. Valleys widened, ridges softened. Features that had survived exposure were erased in motion. The energy involved was continental in scale. The volume of water moving through the narrow western opening surpassed that of all modern rivers combined. This was not sustained gently over ages. It happened rapidly by geological standards, compressing change into a span that left unmistakable scars. Waterfalls formed where the ocean crossed into the lowered basin. Not waterfalls measured against human landscapes, but cascades that descended farther than any modern cliff. Sheets of water fell continuously, carving and reshaping rock beneath them. Mist filled the air. Spray carried minerals and sediments outward, settling across newly flooded regions. As water reached the deepest parts of the basin, it spread outward, racing along the floor, filling depressions first, then climbing steadily upward. The sea did not rise evenly. It surged, paused briefly as space filled, then surged again. Salt crusts dissolved rapidly, disappearing under the returning water. Chemical extremes collapsed as mixing resumed. Isolated basins reconnected not through gentle merging, but through overwhelming force. Boundaries vanished as water reclaimed every low point. The flood did not simply refill the Mediterranean, it reorganized it. Sediments were redistributed across enormous distances. Layers that had formed quietly over long intervals were buried beneath thick deposits laid down in motion. The geological record compressed, marking this event as a sharp boundary between states. Despite its intensity, the flood followed physical laws with precision. Water flowed where gravity led it. Energy dissipated gradually as the basin filled. Over time, the rate of change slowed. The most violent phase passed as levels rose and the height difference diminished. Yet the transformation was complete. In a relatively short span of geological time, the Mediterranean shifted from near desiccation to a fully connected sea once more. The environment that had existed just before the flood was sealed beneath water and sediment, preserved but no longer active. Life would return later, cautiously and in stages, but during the flood itself, biology was secondary. This was a moment governed by physics alone. The planet was equalizing a difference it could no longer tolerate. From afar in time, this event stands unmatched. Earth has seen many floods, many reshaping forces, but none that combined such volume, such height difference, and such sustained power in a single release. It was the planet correcting an imbalance it had allowed to persist for too long. When the waters finally slowed and settled, the Mediterranean was no longer empty, broken, or isolated. It was full again. Calm would eventually return to its surface. But beneath that calm lay a landscape forever altered by the greatest flood the earth has ever known. As the great flood continued, its movement followed a path shaped by depth and gravity rather than direction alone. The Atlantic did not simply spill sideways into the Mediterranean. It dropped. The lowered basin turned the incoming ocean into a descending force, creating waterfalls on a scale the planet has not repeated since. At the western edge of the basin, water crossed the threshold and plunged downward into space that had once been filled by air and salt crusts. The height of this descent exceeded any mountain cliff known today. What existed was not a single waterfall, but a broad, continuous curtain of falling water stretching across the narrow opening. The refilling likely occurred in phases. At first, water rushed into the deepest parts of the basin, forming powerful downflows that cut into rock and sediment alike. These early cascades were narrow and concentrated, guided by the shape of the passage. As erosion widened the channel, the flow expanded, increasing volume rather than slowing it. Nothing in the modern world compares because nothing today combines such height, volume, and persistence. Modern waterfalls descend hundreds of meters at most, fed by rivers constrained by rainfall and terrain. This event involved an ocean falling kilometers, driven by global sea level and gravity alone. The energy released at the base of these falls reshaped everything it touched. Rock fractured under repeated impact. Sediments were lifted and carried away in turbulent clouds. The basin floor became a moving surface, scoured clean in some places and buried deeply in others. As water spread outward from the deepest regions, it surged across the basin like a rising tide accelerated by momentum. Valleys carved during the dry phase were flooded in minutes by geological standards. Their walls softened, edges collapsed, and shapes were smoothed under constant flow. The refilling did not occur evenly. Deep pockets filled rapidly, while higher regions remained exposed longer. This uneven rise created additional cascades within the basin itself. Water spilled from one depression into another, forming internal waterfalls that moved across the landscape as levels climbed. Each of these internal falls carried its own force. Smaller than the initial descent from the Atlantic, but still immense, they carved channels and redistributed sediment in patterns that would later be sealed beneath calmer seas. The basin acted like a vast staircase, each step temporarily holding water before surrendering it to the next. The process repeated again and again, erasing the sharp contrasts that had formed during desiccation. As the water level rose, the intensity of the falls gradually decreased. The height difference shrank, energy dispersed across a wider area. The flood transitioned from vertical motion to horizontal spread, slowing as the basin approached equilibrium. Yet the legacy of those towering waterfalls remained. Landscapes were flattened where force had been greatest. Elsewhere, thick sediment blankets preserved contours shaped by rushing water. The basin's modern shape reflects this moment, even if its surface now appears calm. This refilling was not gentle restoration, it was violent renewal. The Mediterranean was rebuilt, not by patience, but by motion. In a short span of deep time, the basin transformed from a dry, fractured landscape into a unified sea once more. The reason nothing like this happens today lies in Earth's current balance. No modern basin sits thousands of meters below global sea level while remaining connected to an open ocean. Plate movements and climate have not aligned in the same way since. The waterfalls, taller than mountains, existed because the planet briefly allowed such a configuration. When balance returned, the conditions vanished with it. What remains is a hidden memory. Beneath the Mediterranean's surface, shaped valleys, smoothed ridges, and buried channels preserve the record of water moving with unimaginable power. The sea above them appears tranquil, offering no hint of the motion that once defined its return. In this way, the Mediterranean carries within it the imprint of a moment when gravity, water, and land reshaped one another in motion, leaving behind a sea that looks timeless, yet was reborn in a single, extraordinary descent. As the last of the great cascades diminished, the Mediterranean entered a phase that still surprises those who study it closely. The basin did not linger half full. It did not take millions of years to rise again. Instead, the refilling of an entire sea unfolded with a speed that felt almost out of place in Earth's usually patient rhythm. Once the barrier had failed and water flowed freely, time compressed. Estimates drawn from sediment layers, erosion patterns, and chemical signals suggest that the Mediterranean rose from near desiccation to a fully marine state in a remarkably short span. What had taken a long, uneven period to empty was reversed far more quickly. The basin filled not over tens of millions of years, but within a window that may have lasted only thousands of years, perhaps even less. For geology, this is sudden. Scientists were stunned not because the sea refilled, but because of how decisively it did so. Most large-scale environmental changes unfold slowly, step by step, leaving long transitions in the record. Here, the transition was sharp. Thick marine sediments appeared almost immediately above layers of salt and erosion. The boundary between absence and presence was clean, abrupt, and unmistakable. This rapid return defied intuition. Evaporation had drained the basin steadily, with feedbacks that reinforced loss. Recovery, by contrast, required only one thing: an open path and a height difference. Once those existed, gravity did the rest. The Mediterranean was, in effect, a giant empty container placed below sea level and suddenly connected to the global ocean. Water did not need to be persuaded. It did not need favorable climate or slow accumulation. It moved because it could. The speed of refilling also explains why so much of the earlier landscape was preserved beneath the sea. There was little time for erosion by air or slow sediment buildup to soften features further. Valleys carved during the dry phase were submerged and sealed quickly. Salt layers were buried intact. The record was locked in place. Compared to the drawn-out process of loss, this return was efficient. Loss depended on imbalance maintained over long periods. Recovery depended on release. One was patient, the other was decisive. This contrast reshaped how scientists think about stability. It showed that collapse and recovery do not need to mirror one another. Systems can fail slowly and recover quickly, or the reverse. Time does not move symmetrically when thresholds are involved. The rapid refilling also influenced the return of life. Marine organisms did not recolonize a gradually warming basin. They entered a sea that had already regained depth, circulation, and connection. Recovery of ecosystems still took time, but the physical environment they returned to was already recognizable as a sea. Sediment cores taken from the Mediterranean floor reveal this transition clearly. Below, layers speak of extreme evaporation and chemical stress. Above, marine conditions resume abruptly. Between them lies only a thin interval marking the flood itself, a brief but powerful chapter. What makes this event especially striking is how little warning it left behind. Without careful study, the Mediterranean appears stable and ancient. Its modern form gives no hint that it was once nearly gone, or that it returned with such speed. The refilling was faster than the loss, because the forces involved changed direction. Evaporation is limited by climate and surface area. Inflow, once unrestricted, was limited only by gravity and the size of the opening. The basin filled until balance returned, then slowed naturally as levels equalized. By the time the Mediterranean reached its present range, the extraordinary phase had already passed. Currents normalized, coastlines stabilized. The sea resumed the quiet exchange that sustains it today. Yet, the implications remain. This event showed that Earth can move quickly when conditions align. Seas can vanish and return within spans short enough to challenge assumptions about permanence. The Mediterranean did not recover because it was protected. It recovered because physics allowed it to, and once allowed, recovery outpaced loss. The sea that exists today is the result of that rapid return. Calm, familiar, and seemingly timeless. It carries within it the memory of a moment when an entire ocean basin refilled faster than anyone once believed possible. As the waters settled and circulation steadied, the Mediterranean began another quiet transformation. This one did not arrive with force or noise. It arrived through patience. Life returned not as a surge, but as a careful occupation of newly restored space. The refilled sea was physically complete before it was biologically alive. Water moved again between basins, temperatures moderated, salinity softened toward familiar ranges. Only then did living things begin to follow the paths reopened by currents. Recolonization came from the outside. The Atlantic, still full and connected, served as the source. Microscopic life arrived first, carried invisibly by flowing water. Plankton drifted into the basin, multiplying quickly where chemistry allowed. These tiny organisms rebuilt the base of the food web, turning empty water into living space. With them came bacteria and algae, spreading across surfaces newly submerged. They coated rocks and sediments in thin films, beginning the slow work of stabilizing chemistry and capturing energy from light. The sea's color shifted subtly as productivity returned. Small invertebrates followed. Creatures with short life cycles and flexible tolerances moved in with the currents. Some settled quickly, others passed through, testing conditions before establishing themselves. Shell builders returned cautiously, rebuilding where minerals once again supported growth. Fish arrived later, their movements guided by currents and food rather than memory. Species adapted to open water entered first, roaming widely without dependence on specific habitats. Reef associated species lagged behind, waiting for structures and ecosystems to reform. Not all regions recovered at the same pace. Areas closest to the western opening filled with life sooner, refreshed continuously by Atlantic exchange. More enclosed regions took longer, their conditions stabilizing gradually as circulation improved. Recovery unfolded unevenly, basin by basin. Some lineages returned easily, resembling their earlier forms so closely that only careful study reveals the interruption. Others came back altered, shaped by time spent elsewhere or by the bottlenecks of recolonization. The Mediterranean's modern biodiversity carries this imprint of absence and return. Yet not everything came back. Species that had been highly specialized, tied closely to the former chemistry or geography of the basin, were lost permanently. Those that depended on stable, shallow seas or long, uninterrupted histories vanished with the environments that supported them. Their absence is marked not by remains, but by silence in the record. Large, slow reproducing organisms struggled to reestablish themselves. Their life strategies could not compete in a rapidly changing system. Some were replaced by relatives better suited to variability. Others left gaps that were never filled in the same way. The returning Mediterranean was similar, but not identical, to the sea that had disappeared. It carried fewer endemic species and more generalists. Its ecosystems were rebuilt under new constraints, shaped by the memory of instability. This pattern reflects a broader truth about recovery. Return does not mean restoration. When life recolonizes after extreme change, it assembles what fits, not what was lost. The past shapes the present, but it does not fully reappear. Over time, complexity increased, food webs lengthened, habitats diversified, reefs expanded where conditions permitted. The sea regained its rhythms, its seasonal pulses, its migrations. To an observer far removed in time, it would appear whole again. Beneath the surface, however, the imprint of loss remained. Genetic diversity was reduced in some groups. Distribution patterns shifted. The Mediterranean became a sea marked by resilience, but also by constraint. The return of life was slower than the return of water, but it was steady. Each generation built upon the last, filling niches left empty, adapting to a basin that had learned how close it came to disappearance. In this way, the Mediterranean became a living archive. Its species tell a story of survival through movement, of persistence through flexibility, and of limits revealed by absence. The sea above the salt layers grew busy again, animated by countless forms of life. Yet within that abundance lies a quiet reminder. Not everything that leaves returns, and what comes back is shaped forever by the moment when the water was gone. The Mediterranean we know today appears settled, almost timeless. Its shores feel permanent, its rhythms familiar. Yet the sea we inherited is not a pristine continuation of the past. It is a recovery, a system rebuilt after a profound interruption. Following its rapid refilling and the gradual return of life, the Mediterranean settled into a new balance, Water once again exchanged steadily with the Atlantic. Salinity stabilized within tolerable ranges. Circulation patterns formed that resemble those observed today. From the surface, the sea regained an appearance of continuity. Beneath that surface, however, the basin tells a more complex story. Hidden scars remain everywhere. The seafloor holds thick salt layers laid down during its near disappearance, now buried beneath younger sediments. These layers deform the crust slightly under their weight, influencing how the seafloor bends and breaks. In some places, they even shape how modern faults behave. Buried river canyons cut deep into the continental margins remain preserved below the waves. They no longer guide rivers, but they influence currents and sediment flow. Their presence alters how water moves along the seafloor, shaping modern deposits in subtle ways. The basin's depth itself reflects catastrophe. Much of the Mediterranean floor lies deeper than would be expected for a sea of its age and size. This depth is not simply the result of tectonic stretching. It was accentuated by erosion during the dry phase and scouring during the flood that followed. The basin was carved downward, then filled again. Even the shape of the coastline carries memory. Some shelves are unusually steep, others extend farther than typical continental margins. These features record rapid changes in sea level, rather than slow, steady adjustment. They are legacies of retreat and return. The Mediterranean's modern circulation also bears the imprint of its recovery. Dense, salty water still forms and sinks, flowing outward beneath incoming Atlantic water. This pattern echoes the conditions that once made the sea vulnerable. The same delicate balance remains in place, even if it is now stable. Biologically, the sea reflects its history as well. Many species living here are relatively young in evolutionary terms, having recolonized after the crisis. Endemic species exist, but fewer than might be expected for a basin of this age. Diversity is shaped by openness rather than isolation. Some habitats appear productive yet simplified, others are unusually sensitive to change. These traits trace back to a sea that had to rebuild rather than persist. The Mediterranean sediments tell the story most clearly. Drilling into the seafloor reveals a sharp transition from salt and erosion to normal marine deposits. There is no gradual blending, only a line marking transformation. Above it lies the sea we recognize. Below it lies a world that no longer exists. What we see today is therefore not a default state. It is the result of survival through narrow margins. The Mediterranean did not remain because it was guaranteed. It remained because conditions allowed recovery before permanence took hold. This understanding reframes how stability is perceived. The sea looks calm not because it has always been so, but because its most violent changes are buried. Time smooths surfaces and hides extremes. The Mediterranean we inherited carries resilience shaped by disruption. It functions well under certain conditions, but it is not immune to imbalance. Its past shows how sensitive it can be to shifts in connection, climate, and circulation. Every wave moving across its surface travels above layers that remember when water was absent, when salt crystallized, when rivers cut downward into exposed land. Those memories do not influence daily tides, but they influence the basin's long-term behavior. To know this sea fully is to understand it as a survivor. It is not an ancient constant, but a recovered system, shaped as much by what nearly erased it as by what sustains it now. The Mediterranean we inherited is calm, but not innocent of history. Its quiet hides a record of catastrophe, preserved beneath the water, waiting patiently for those who know where to look. Long after the Mediterranean returned to a familiar shape, the evidence of what happened never left. It did not fade with waves or currents. It settled beneath them, sealed under layers of sediment, protected from erosion by the very water that came back to cover it. The sea recovered, but the memory remained. Beneath the modern seafloor lie vast sheets of salt, laid down during the time when water vanished and chemistry ruled. These layers are not thin or scattered. They stretch across much of the basin, stacked in sequences that can reach extraordinary thickness. Each layer marks a moment when evaporation outpaced renewal, when water retreated and minerals stayed behind. These salt deposits behave differently from ordinary rock. They flow slowly under pressure, bending and warping the layers above them. Over time, they push upward, creating subtle domes and ridges in the seafloor. In some regions, they influence where faults form and how sediments accumulate. The Mediterranean's present structure is still shaped by salt that formed when it nearly disappeared. Drilling into the seafloor reveals these layers clearly. Above them lie normal marine sediments, fine muds and shells settling quietly through water. Below them, the salt appears abruptly, dense and crystalline. There is no gradual transition. The boundary between absence and return is sharp, preserved like a line drawn across time. Along the margins of the basin, another form of memory lies hidden. Buried river valleys cut deep into bedrock, far below the level of today's sea. These valleys were carved when rivers suddenly had somewhere to fall, slicing downward as the Mediterranean dropped beneath them. When the sea returned, these channels drowned and filled with sediment, disappearing from the surface. They are invisible to the eye, but not to instruments. Seismic surveys trace their shapes beneath the seafloor, revealing winding paths that follow ancient landscapes rather than modern coastlines. Some descend deeper than the Grand Canyon, a depth that makes sense only when the sea itself was far lower than it is now. These valleys tell a precise story. Rivers did not slowly erode them over endless time. They cut quickly, responding to sudden change. Their presence beneath calm water confirms that the basin was once open land, shaped by gravity rather than tides. Together, the salt layers and buried valleys form a complete record of extremes. One speaks of dryness and chemical concentration. The other speaks of flowing water and downward force. Both exist beneath the same sea, separated only by time. What makes this record remarkable is how well it has been preserved. The flood that refilled the Mediterranean did not erase what came before. It buried it. Sediments laid down during refilling and afterward sealed the earlier landscape, locking it away from surface processes. Unlike land, which is constantly reshaped by weather and erosion, the seafloor protects what lies beneath. This preservation allows scientists to read Earth's memory with clarity. Each layer, each buried feature, acts like a sentence in a long geological story. Together, they describe a sequence of loss, fragmentation, and return that would otherwise be difficult to imagine. Earth does not remember through recollection. It remembers through structure. What happened is written into stone, salt, and sediment, waiting patiently until someone looks closely enough to notice. The Mediterranean is not unique in this way, but it is one of the clearest examples. Few places on Earth preserve such an extreme transformation so cleanly beneath a surface that appears ordinary. The contrast between calm water above and extraordinary history below is striking. Every modern ship crossing the Mediterranean passes over landscapes that were once deserts, river valleys, and salt flats. Every wave moves above evidence of a sea that failed, then returned. None of this is visible without effort, yet all of it remains. This is how Earth preserves its past, not in monuments, but in layers, not in stories, but in form. The Mediterranean carries its memory quietly beneath the water, unchanged by the passage of human time. The evidence is still there, resting below us, a reminder that what looks permanent is often only the latest chapter written on top of many others. Even with salt layers mapped, valleys traced, and sediments dated, the story of the Mediterranean's disappearance remains open to debate. The broad outline is clear, yet the details resist final agreement. Scientists still argue not because the evidence is weak, but because it is incomplete in ways that matter. Different models attempt to explain how the sequence unfolded. Some emphasize a slow constriction of connections, where tectonic uplift and sediment gradually narrowed the gateway until exchange weakened beyond recovery. In these views, loss accelerated step by step, guided by climate and geometry, working together over long spans of time. Other models focus on more abrupt changes. They suggest that once a threshold was crossed, decline happened rapidly, driven by runaway feedbacks rather than steady adjustment. In these reconstructions, the Mediterranean fell faster, fragmented sooner, and approached desiccation more decisively. There are also disagreements about the refilling itself. Some reconstructions picture a single overwhelming flood that restored the sea in one dramatic event. Others allow for multiple pulses, where the basin filled, stabilized briefly, then surged again as pathways widened further. Each interpretation fits parts of the record, but none explains all of it perfectly. What complicates matters is the nature of the evidence. Much of what scientists rely on lies buried deep beneath the seafloor, accessible only through drilling and indirect imaging. Each core represents a narrow window into a vast basin. Between those points, interpretation must bridge gaps. Salt layers tell when evaporation dominated, but they do not always reveal exactly how fast it happened. Erosion surfaces show exposure, but not how long land remained dry. Sediments deposited during refilling record movement, but compress events that may have unfolded over centuries into layers that appear nearly instantaneous. Time itself becomes slippery at this scale. Geological clocks are precise over long spans, but struggle with short, intense events. 1,000 years can vanish into a line too thin to resolve clearly. What feels sudden in the record may still have been gradual by human standards, or vice versa. Another challenge lies in the shifting shape of the basin. The Mediterranean did not behave as a single container throughout this episode. It broke into basins, each responding differently. Evidence from one region may not match evidence from another, yet both can be correct locally. Climate adds another layer of uncertainty. Changes in rainfall, temperature, and wind patterns influenced evaporation and inflow, but reconstructing those conditions precisely remains difficult. Climate signals preserved on land and in oceans elsewhere do not always align neatly with what the Mediterranean record suggests. Tectonics complicate the picture further. Land movement is rarely uniform. Uplift and subsidence vary across short distances. A gateway that appears open in one reconstruction might have been shallow or intermittent in reality. Small differences in elevation matter greatly when water balance hangs in the margin. Because of this, certainty remains elusive. Each new dataset refines the story, but often introduces new questions. Improved imaging reveals features that require explanation. Better dating sharpens timelines, sometimes compressing events more tightly than before. Disagreement, in this case, is not failure. It reflects the complexity of Earth systems and the limits of what can be preserved. The Mediterranean episode sits at the intersection of climate, tectonics, oceanography, and chemistry. Few events combine so many influences at once. What all models share is recognition of vulnerability. No matter how the details are arranged, the Mediterranean depended on narrow connections and delicate balance. Once those were strained, the system responded dramatically. The arguments continue because the stakes are high. Understanding how close the Mediterranean came to permanence and how quickly it recovered reshapes how scientists think about stability elsewhere. Similar basins exist across Earth's history, and some may yet form again. In this way, uncertainty becomes productive. It keeps the story alive, open to revision, and grounded in evidence rather than closure. The Mediterranean does not offer a single clean lesson. It offers a layered one, preserved beneath water and debate alike. The sea that looks calm today carries a history complex enough that even now, with decades of study, Earth has not finished explaining itself. When people speak of geological change, they often imagine patience stretched across eternity. Mountains rise grain by grain, oceans open and close over ages so long they feel abstract. Earth is taught as a slow storyteller, turning pages only after millions of years have passed. Against that expectation, the Mediterranean episode sits uneasily. For a planet, speed is relative. What feels ancient to human memory can be brief in geological terms. 1,000 years is an empire to us, but to Earth it can register as a moment, barely thick enough to leave a visible line in stone. The Mediterranean reminds us of this difference in scale. The loss of the sea unfolded over a long and uneven span, paced by climate, tectonics, and evaporation. It felt slow even by geological standards, marked by repeated hesitation and partial collapse. The return, however, moved differently. Once the threshold was crossed, time compressed. What followed happened quickly, not in the language of calendars, but in the language of layers. Sediments laid down after refilling show how abrupt the transition was. One moment, salt and erosion dominate. The next, marine life and calm deposition resume. Between them lies a boundary thin enough to challenge expectation. Earth, usually patient, acted decisively. This is where human intuition struggles. We expect large systems to change slowly and small systems to change quickly. Yet the Mediterranean was vast, continental in scale, and it shifted states faster than many local environments do. A whole sea transformed more quickly than forests migrate or ice sheets advance. The reason lies not in size alone, but in thresholds. When systems operate within stable ranges, change is gradual. Feedbacks dampen motion, but when boundaries are crossed, behavior changes. The same forces that once resisted movement begin to amplify it. The Mediterranean had crossed such a boundary. Once connection was restored, gravity replaced hesitation. The basin filled because it could, not because conditions were carefully balanced. In that moment, Earth did not move slowly. It moved efficiently. For scientists trained to think in long spans, this realization required adjustment. The record showed that large-scale change could occur within intervals short enough to matter for ecosystems and landscapes. Stability was revealed as conditional, not guaranteed. This event broke expectations because it refused to fit the usual pattern. Collapse was drawn out, recovery was rapid. The symmetry often assumed between loss and gain did not hold. Earth does not promise balance in how time is distributed. This challenges how slow change itself is understood. Slowness is not a constant property of geological systems. It is a behavior that emerges under certain conditions. When those conditions change, speed follows. The Mediterranean also forces a reconsideration of what counts as fast. 1,000 years can erase entire environments if forces align. 10,000 years can redraw continents in meaningful ways. These spans are invisible to human memory, yet brief to Earth. By placing human time beside geological time, the mismatch becomes clear. Humans build cities assuming coastlines will remain where they are. Earth measures coastlines as temporary arrangements. What seems fixed within a lifetime may be flexible across a few layers of sediment. The lesson is not that Earth is unpredictable, but that it is responsive. It follows rules faithfully, even when outcomes surprise those watching from one moment in time. When imbalance persists, correction can arrive suddenly. The Mediterranean's return does not stand alone. Other events in Earth's history show similar behavior. Ice sheets retreat faster than they advance. Rivers carve quickly when slopes steepen. Ecosystems reorganize rapidly after thresholds are crossed. Together, these moments suggest that slow change is not the only mode Earth possesses. It is simply the most visible one when systems remain within comfort. Understanding this reshapes how stability is viewed. A calm surface does not always indicate slow underlying motion. Sometimes it means forces are quietly accumulating, waiting for release. The Mediterranean teaches this without drama. Its waters appear steady today, yet beneath them lies evidence of a time when an entire sea returned faster than many expected possible. In learning how fast can be for a planet, we learn something quieter as well. Earth is not slow by nature. It is patient until it no longer needs to be. With the Mediterranean restored and familiar, it is tempting to place its disappearance firmly in the past. The forces that drained it feel distant, belonging to another configuration of continents and climates. Yet Earth does not retire its mechanisms, it rearranges them, and so the question of repetition lingers quietly beneath the present calm. Today's Mediterranean sits within a different tectonic context than it once did. Africa continues to move northward, pressing slowly against Europe. This motion closes space in some regions while opening it in others. Mountain ranges rise incrementally, basins deepen or tilt. None of this happens quickly, but none of it stops. At Gibraltar, the narrow gate still exists. It remains the Mediterranean's lifeline, the place where balance is maintained through exchange. Modern measurements show that this passage is stable, carved deeply enough that complete closure is not expected under present conditions. The Atlantic continues to flow inward reliably, replacing water lost to evaporation. Climate, too, plays a stabilizing role. While the Mediterranean remains a region of strong evaporation, global sea levels and circulation patterns currently favor sustained inflow. Rivers continue to contribute. Rainfall, though variable, supports balance rather than undermines it. Taken together, these factors make a repeat of the ancient near disappearance, unlikely in the foreseeable future. The precise alignment of tectonics, sea level, and climate that once allowed such extreme imbalance no longer exists in the same way. Yet unlikely does not mean impossible. Earth's history shows that conditions can change in combinations that are difficult to anticipate. Tectonic motion never pauses. Over very long spans, passages can narrow, uplift can occur, and basins can be reshaped. Climate can drift into warmer or drier regimes for extended intervals. Sea level can fall globally during periods of widespread glaciation. If such changes were to coincide again, the Mediterranean's vulnerability would reemerge. Its fundamental structure has not changed. It is still an enclosed sea that loses more water to the sky than it gains from rain and rivers. It still depends on outside connection to survive. The same arithmetic remains quietly in place. This is the long-term vulnerability the Mediterranean carries, not as an immediate threat, but as a structural condition. The sea exists because balance is maintained. Should that balance fail for long enough, the system would respond as it has before. The difference today lies in timescale. Any repetition would unfold over spans far longer than human planning or memory. It would not be a sudden surprise. It would begin with subtle shifts, barely noticed, accumulating quietly across thousands of years. This perspective reshapes how permanence is understood. The Mediterranean is stable now because conditions allow it to be. It is not protected by design, it is permitted by circumstance. Understanding this does not make the present fragile, it makes it conditional. The Mediterranean's past shows that even vast bodies of water can be temporary features in Earth's story. Seas come and go, connections open and close. Landscapes that feel eternal are often provisional. What makes a repeat unlikely is not immunity, but alignment. Today's Earth is arranged differently, but alignment is something Earth revisits, not something it avoids. The value of this story lies not in predicting repetition, but in recognizing pattern. The same principles apply elsewhere, to other enclosed seas, to future basins yet to form. Balance maintained through narrow connections always carries risk, however distant. The Mediterranean stands as an example not of danger, but of contingency. Its calm surface rests on a long history of negotiation between forces that never stop acting. As the story of this sea settles back into the present, it carries a quiet truth forward. What exists now is stable because it works, not because it must. Earth does not promise repetition, but it never promises permanence either. The story of the Mediterranean leaves behind more than layers of salt and buried valleys. It leaves a lesson about stability itself, not as an abstract idea, but as a lived condition shaped by balance, timing, and restraint. Many systems on Earth appear permanent because they persist across human memory. Seas hold their shorelines, mountains hold their silhouettes. Climate settles into patterns that feel reliable. From within a single lifetime, these features seem fixed, almost guaranteed. Yet the Mediterranean shows how permanence can be an illusion created by duration rather than design. The sea looked stable for millions of years before it nearly vanished. It looks stable again now. In both cases, stability was real, but conditional. It existed because opposing forces happened to cancel one another out for a time. Evaporation was matched by inflow. Movement was balanced by resistance. Nothing dramatic needed to happen for the system to hold. Balance, however, is not a static achievement. It is an active process that must be maintained continuously. When one side of the equation shifts, even slightly, the entire system responds. The Mediterranean did not fail because it was weak. It failed because its balance depended on narrow margins. This is the illusion that calm surfaces create. When change is slow or invisible, it is easy to assume nothing is happening. Yet beneath the surface, forces are always at work. Heat rises, land moves, water circulates. Over time, these motions accumulate whether or not they announce themselves. The Mediterranean teaches that stability is not the absence of motion, but the management of it. As long as inputs and outputs remain aligned, the system appears steady. Once alignment slips, change accelerates. This lesson applies beyond oceans. Ice sheets advance and retreat under similar rules. Forests persist while conditions support them, then reorganize quickly when thresholds are crossed. River systems adjust gradually, then carve rapidly when slopes steepen. In each case, fragility hides beneath familiarity. What makes fragility difficult to recognize is that it does not feel fragile while balance holds. The Mediterranean did not show signs of imminent collapse until it was already well underway. Early changes were subtle, distributed, and reversible. Only later did feedbacks amplify loss. By the time instability becomes obvious, options narrow. The illusion of balance is reinforced by repetition. When conditions remain similar year after year, confidence grows. Systems appear to earn trust simply by continuing, yet trust does not alter physics. It only delays awareness. The Mediterranean's near disappearance reminds us that large systems can hinge on small connections, a narrow passage, a slight uplift, a persistent climate pattern. These do not look dramatic, but they matter immensely when balance depends on them. Fragility, in this sense, does not mean weakness, it means sensitivity. A system can be robust in many ways and still vulnerable to specific changes. The Mediterranean survived storms, fluctuations, and biological turnover. What it could not survive indefinitely was a sustained imbalance at its boundary. This reframes how calm should be interpreted. Calm is not proof of permanence, it is a snapshot of equilibrium at a particular moment. Beneath it, the same forces that once reshaped the basin remain active. Understanding this does not invite alarm, it invites perspective. Earth's systems are not brittle, but they are responsive. They adapt, shift, and sometimes transform entirely when conditions demand it. The Mediterranean did not betray expectations. Expectations were built on limited timescales. Stability, as Earth practices it, is dynamic. It allows change, absorbs stress, and adjusts continuously. When adjustment becomes impossible, transformation follows. The calm sea today is real. Its waves are gentle. Its cycles are predictable. Yet beneath that calm lies a history that proves how conditional such states can be. The lesson is quiet but enduring. What appears permanent often survives only because balance still holds. And balance, while powerful, is never guaranteed. In recognizing the fragility beneath calm surfaces, we do not diminish Earth's strength, we understand it more clearly. The Mediterranean story fits into a larger pattern that Earth repeats quietly. Oceans and seas feel permanent because they outlast generations, civilizations, and written memory. Yet on geological timescales, water bodies are among the most temporary features the planet creates. Earth has hosted many seas that no longer exist. Vast inland oceans once covered regions that are now deserts or mountain ranges. Shallow epicontinental seas spread across continents during warmer periods, then vanished as climates cooled or land rose. Their shorelines are traced today only by fossils embedded far from any modern coast. These seas did not disappear through catastrophe alone. Some drained as connections narrowed, others evaporated as climates shifted. Some were lifted high above sea level by slow tectonic motion, transformed into plateaus and folded rock. In each case, water retreated and geography changed without drama. The planet is skilled at erasing its own features. Coastlines migrate, basins fill with sediment, waterways reroute. What once defined a landscape can be softened, buried, or removed entirely. Earth rarely preserves a surface exactly as it was. It replaces it. This habit of erasure is not destructive. It is part of how the planet stays dynamic. Sediments move nutrients. Land rises and falls. Oceans open and close as continents drift. Over long spans, these motions refresh environments rather than freeze them. The Mediterranean nearly joined the long list of vanished seas. Its narrow escape reminds us how common disappearance truly is. Had conditions shifted slightly further, its basin might now be a salt filled depression, perhaps mistaken for an ancient desert rather than the remains of a sea. Other examples surround us. The Paratethys Sea once stretched across much of Eurasia, connecting regions now separated by mountains and plains. It fragmented and disappeared as land rose and connections failed. The Western Interior Seaway once split North America in two, hosting marine life where grasslands now extend. It drained as continents changed shape. Even the oceans we know today are temporary. The Atlantic itself is opening slowly, widening year by year as tectonic forces pull continents apart. In time, it too will close, consumed by subduction elsewhere. This cycle has repeated before and will repeat again. Temporary geography is Earth's default state. Continents rearrange, seas migrate. What exists now is simply what exists at this moment. This perspective shifts how stability is understood. Seas do not remain because they are meant to. They remain because conditions allow them to. When those conditions change, water obeys gravity and physics, not memory. The Mediterranean teaches this gently. Its survival was not guaranteed by size or history. It depended on narrow connections, delicate balance, and timing. That combination held long enough for recovery, but it easily could have failed. The evidence beneath the sea confirms this truth. Salt layers and buried valleys record a moment when geography was rewritten. That record is not unique. Similar layers exist beneath other seas and across continents, marking episodes when water arrived, lingered, and left. Earth does not mark these transitions with signs or warnings. It simply moves forward. Landscapes that feel ancient are often recent. Features that seem permanent may vanish quietly under new arrangements. Understanding that oceans are not guaranteed does not make the present fragile. It makes it contextual. The seas we know are chapters, not conclusions. The Mediterranean we inherited exists because it returned, not because it always remained. Other seas were not as fortunate. Their stories ended without recovery, their basins filled with rock, salt, or air instead of water. In this way, the planet reminds us that geography is temporary by nature. Water shapes land, land reshapes water, and time reshapes both. The calm surface of any sea hides this truth. Beneath it lies a history of arrival and departure, preserved not to warn, but to be read. Oceans are powerful, but they are not promised. They exist only while Earth allows them to. Humanity has always lived among features that appear steady. Coastlines repeat themselves year after year. Seas return the same reflections each morning. Mountains hold their outlines through generations of stories and maps. Surrounded by this continuity, it becomes natural to assume permanence. This assumption is not careless. It is practical. Human lives are brief, and within those spans, most of Earth behaves predictably. The Mediterranean does not vanish between childhood and old age. Rivers do not reverse overnight. The ground beneath cities does not usually rise or fall in ways that demand attention. Stability feels earned simply because it lasts long enough to feel reliable. Memory reinforces this comfort. What we experience repeatedly becomes expectation. When parents and grandparents describe the same shorelines, the same harbors, the same seasons, permanence settles into the mind as a quiet rule. Geography becomes background rather than participant. Geology does not share this perspective. The planet measures time differently. It does not weigh decades heavily. It records movement in layers, not lifetimes. To geology, 1,000 years can be a brief interruption. 10,000 years can be a pause between states. Even events that feel unimaginably slow to us can register as quick shifts in the rock record. From that longer view, Earth rarely stands still. Continents drift, basins deepen or fill, water arrives, lingers, and departs. What humans treat as fixed reference points are often temporary arrangements. The Mediterranean story reveals this disagreement clearly. For human history, the sea has always been there. It framed trade, culture, and climate. It feels ancient and dependable. Yet geology shows that this state is recent relative to Earth's history and that it nearly failed to exist at all. This contrast is uncomfortable because it challenges trust. If something as vast as a sea can vanish and return, what else might be less permanent than it seems? Geology answers without urgency. Many things. The comfort of forgetting serves a purpose. It allows societies to plan, build, and grow without constant fear of change. It allows attention to focus on the immediate rather than the hypothetical. Without this forgetting, daily life would feel fragile beyond usefulness. Yet forgetting has limits. When permanence is assumed too deeply, vulnerability becomes invisible. Subtle changes are dismissed. Long-term processes are ignored because they do not align with human timescales. The Earth continues its work regardless. Geology does not argue against human memory. It simply operates outside it. Rock layers record events without regard for whether they were witnessed. Salt accumulates without caring if anyone is present to see it. Rivers carve valleys whether or not the change is noticed. This difference in perspective explains why geological surprises feel unsettling. They reveal that calm does not equal stillness, and familiarity does not equal permanence. The Mediterranean nearly disappeared without anyone to observe it. Its return reshaped continents without leaving a surface monument. Only later, through careful reading of stone and sediment, did the story emerge. Earth does not announce its turning points. It leaves them quietly behind. Humanity prefers stories that end cleanly. A stable sea, a finished landscape, a world that behaves tomorrow as it did yesterday. Geology prefers stories that continue, revise, and overwrite. The comfort of forgetting is therefore a temporary agreement between perception and reality. It works as long as conditions remain within familiar bounds. When they do not, memory proves insufficient. This does not mean humanity is wrong to feel grounded. It means grounding must be understood as provisional. The ground itself has a history of movement. The Mediterranean today invites calm. Its surface reflects light softly. Its tides repeat. It gives no hint of absence. Forgetting its past feels harmless. Yet beneath the water lies evidence that forgetting is incomplete. Geology disagrees with permanence not to alarm, but to remind. Earth's stability is conditional, negotiated moment by moment across immense spans of time. Humanity carries short memory because it must. The planet carries long memory because it can. Between these two perspectives lies the full story. A world that feels steady within a lifetime, yet remains capable of transformation beyond it. Earth does not follow a single script. It explores possibilities. Across its long history, the planet has tested extremes again and again, not with intention, but through the interaction of forces that never stop moving. Climate shifts, continents drift, oceans open and close. Each combination produces a different outcome, some gentle, some severe. The Mediterranean's near disappearance fits within this larger pattern. It was not an anomaly set apart from the rest of Earth's story. It was one experiment among many, shaped by a particular arrangement of land, water, and heat. When that arrangement changed, the outcome changed with it. Earth behaves like a system that allows conditions to run their course. When balance holds, systems persist. When balance slips, new states emerge. Some of those states are temporary, others last for millions of years. The planet does not intervene to preserve what came before. Extremes arise naturally within this process. Ice sheets grow large enough to reshape circulation, atmospheres thicken or thin, seas retreat or expand. None of this requires catastrophe. It requires only time and interaction. Failure, in this context, is not an ending. It is part of how Earth explores its limits. When a system fails, it reveals where its boundaries lie. The Mediterranean failed to maintain itself under sustained imbalance. That failure exposed how dependent it was on connection and exchange. Across Earth's history, many systems have failed without recovery. Entire ecosystems have vanished. Oceans have closed permanently. Mountain ranges have altered climate patterns so completely that former environments never returned. These failures are not mistakes, they are outcomes. Evolution, both biological and geological, proceeds through this process. Conditions change, systems respond. Those that fit the new conditions persist, those that do not end. Recovery is not promised. It happens only when circumstances allow. The Mediterranean recovered because the pathway for return remained open just long enough. Had that opening closed fully, the basin would have entered a different chapter, one without reversal. Recovery depended on timing, geometry, and chance alignment. This distinction matters. Recovery is often treated as inevitable, as if systems naturally return to familiar states after disruption. Earth's record shows otherwise. Recovery is contingent. It requires favorable conditions that may not exist again. In many cases, Earth experiments once and moves on. The Paratethys Sea did not return. The Western Interior Seaway did not refill. Ancient atmospheres rich in methane did not reappear. Once conditions changed, those experiments ended. The Mediterranean's return was therefore not a guarantee fulfilled, but a possibility realized. Its story includes both failure and fortune. It failed to sustain itself, yet avoided permanence by remaining connected long enough for reversal. This framing reshapes how resilience is understood. Resilience does not mean invincibility. It means survival through alignment. When alignment breaks, resilience ends. Earth's experiments do not aim for balance. Balance emerges when forces counteract one another. When they do not, imbalance becomes the new state. The planet continues regardless. From this perspective, stability appears as a temporary achievement rather than a default condition. It exists where competing influences happen to cancel out. It fades when they do not. The Mediterranean today reflects a successful recovery, but it also reflects the memory of experimentation. Its basin carries evidence of extremes it once experienced. Salt layers, carved valleys, and altered ecosystems all testify to a period when the system behaved very differently. Earth learned nothing from this in a conscious sense. It simply continued. New conditions replaced old ones. Life adapted where possible. Landscapes settled into new forms. This is how the planet evolves, not toward perfection, but through variation. Some paths lead to enduring states, others end abruptly, most lie somewhere in between. Understanding Earth as a planet that experiments removes the expectation of permanence. It replaces it with awareness of possibility. Systems can change dramatically when conditions align. Recovery may follow, or it may not. The Mediterranean's survival is therefore both reassuring and humbling. It shows that recovery can happen, but also that it depends on circumstances that cannot be assumed. Earth does not protect outcomes, it allows processes. In that allowance, experiments continue, quietly and continuously, shaping a planet whose calm surfaces often hide histories of extremes, failures, and rare returns. Catastrophe often arrives in imagination with noise, fire, shock, and sudden endings dominate how destruction is pictured. Explosions mark turning points. Impacts leave scars that can be pointed to easily. Yet the Mediterranean's near disappearance unfolded without any of this. No fireball crossed the sky. No wall of flame swept across continents. Nothing dramatic announced the change. What happened was quieter. The sea did not vanish in a single moment. It thinned, it lowered, it retreated year by year as imbalance accumulated. Evaporation carried water upward into the air. Narrow connections failed to replace what was lost. The process repeated, gently but relentlessly. From a distance, nothing would have looked wrong at first. The shoreline moved slowly, the waterline crept downward. Life adjusted as it could. There was no instant that demanded attention, no moment that clearly marked disaster. This is how the most powerful changes often occur on Earth, through repetition rather than rupture, through patience rather than force. Imbalance does not announce itself. It builds quietly as small differences compound, a little more loss than gain, a little less connection than before. Over time, these small mismatches grow large enough to reshape entire systems. The Mediterranean crossed such a threshold without spectacle. By the time its vulnerability became undeniable, the process had already gained momentum. Fragmentation followed naturally, basins isolated, chemistry shifted, landscapes emerged where water had been. None of this required violence, it required only time. This quietness makes such catastrophes difficult to recognize. Humans are attuned to sudden danger, not gradual drift. We respond to loud signals and sharp edges. Slow change, especially when it feels stable day to day, escapes notice. Geology records many such events. Ice sheets expand silently, year by year, until coastlines are redrawn. Deserts spread gradually, grain by grain, until ecosystems reorganize. Seas retreat without urgency, leaving salt and stone behind. The Mediterranean story fits this pattern. Its near disappearance was not an accident or a surprise to physics. It was the logical outcome of sustained imbalance, left uninterrupted. This kind of catastrophe does not inspire alarm bells. It inspires normalcy until normalcy no longer applies. The danger lies in how easily silence is mistaken for safety. When change is slow, it feels manageable. When each step is small, it feels reversible. Yet accumulation does not reset itself. It carries forward. By the time reversal becomes difficult, the moment for easy correction has passed. The Mediterranean did not collapse suddenly. It reached a point where collapse became the natural continuation of existing trends. No decision was made, no trigger was pulled. The system simply followed its trajectory. Even the recovery, dramatic as it was, came after a long period of quiet change. The flood was loud in geological terms, but it followed silence. It arrived because imbalance had been allowed to persist. This contrast highlights a deeper truth. The most dangerous changes are often those that feel least dramatic while they are happening. They do not interrupt daily life immediately. They do not demand reaction. They allow comfort to continue. Earth's history is filled with such moments. Entire climates shifted without explosions. Mass extinctions unfolded alongside normal days and nights. Landscapes transformed while life carried on unaware of the trajectory it was on. The Mediterranean's near disappearance reminds us that catastrophe does not need spectacle, it needs only imbalance and time. Today, the sea is calm. Waves repeat familiar patterns. The surface gives no hint of how quietly it once slipped away. Its story survives not in scars visible from above, but in layers buried beneath. This quietness is not meant to frighten, it is meant to inform. Earth changes not only through rare violence, but through constant motion. When that motion leans too far in one direction for too long, transformation follows. The lesson rests gently beneath the water. Silence does not mean stillness. Calm does not guarantee stability. The absence of noise does not signal the absence of change. The Mediterranean disappeared almost without a sound and returned long after. Its quiet catastrophe stands as a reminder that the most profound shifts often arrive without announcing themselves at all. The Mediterranean today appears gentle. Its surface catches light softly, shifting from blue to silver as clouds pass overhead. Waves rise and fall in familiar rhythms, shaped by winds that have crossed these waters for generations. To those who travel it now, the sea feels settled, even comforting. This calm is real, but it is also shallow. Beneath the moving surface lies a record of chaos that never fully disappeared. Layers of sediment rest quietly on the seafloor, but below them sit thick sheets of salt, compressed memories of a time when water was scarce and chemistry ruled. These layers do not lie flat like pages in a book. They bend, creep, and press upward slowly under their own weight, reshaping the ground above them over immense spans of time. The seafloor itself is uneven in ways that reveal its past. Submerged valleys cut deep into the margins remain hidden under mud and sand. Slopes drop away more sharply than expected in places where erosion once worked without restraint. The basin floor carries scars smoothed by rushing water and buried by sudden return. Nothing about this is visible from above. The Mediterranean's present normality exists as a thin layer stretched over extremes. Calm water rests atop structures formed in absence, stress, and motion. The sea functions smoothly because those older forces have settled into dormancy, not because they were erased. Currents move steadily now, exchanging water with the Atlantic in a pattern that feels dependable. Salinity remains within narrow bounds. Life thrives across the basin, filling niches rebuilt after disruption. From the surface, there is no sign of instability. Yet the architecture of the sea tells another story. Salt layers continue to influence how sediments stack and how faults respond to pressure. The buried landscape still guides the flow of deep currents. The shape of the basin, carved and reshaped during crisis, determines how energy moves through the water today. In this way, the Mediterranean's past is not gone, it is incorporated. The thin layer of normality that defines the present is supported by deeper structures forged under very different conditions. Remove that calm layer, and the extremes beneath would reappear clearly, but as long as balance holds, the surface remains serene. This contrast is one of Earth's quiet habits. It allows violent histories to fade beneath functional systems. It stacks calm upon chaos and lets time soften the memory without deleting it. The Mediterranean is not unique in this. Many stable environments rest on foundations shaped by earlier extremes. Fertile plains cover ancient seabeds. Forests grow atop volcanic deposits. Cities rise above fault lines, held still by temporary balance. What makes the Mediterranean distinctive is how recent and how complete its transformation was. The distance between absence and abundance here is small in geological terms. The layers separating them are thin. Every modern tide moves above salt that should not exist in an open sea. Every ferry crosses valleys that once lay open to the sky. Every calm evening reflects a surface that conceals one of Earth's most dramatic reversals. This does not make the present fragile in a practical sense. The sea is stable now, its systems function, its balance holds, but it does place that stability in context. Normality, in Earth's language, is often provisional. The Mediterranean's calm is not a denial of its past, but a phase built upon it. The chaos beneath does not threaten the surface daily, but it shapes the boundaries within which the surface can exist. This layered reality invites a different way of seeing. Calm water is not emptiness of history, it is history settled into form. It is motion slowed, not erased. As night falls over the Mediterranean, the surface darkens smoothly. Stars reflect where ancient salt once dried under the sun. The sea breathes quietly, unaware of its own depth of memory. Above, everything feels ordinary. Below, the story remains, pressed into stone and crystal, waiting without urgency. The Mediterranean settles into the present as if it has always been here. Its waters move with quiet confidence. Its coastlines feel familiar, traced and retraced by generations. To live beside it is to feel anchored by something vast and steady. Yet the story carried beneath its surface asks for a gentler kind of attention. The Mediterranean is not a guarantee, it is a reminder. It reminds us that even the most stable-looking systems exist by balance rather than promise. The sea did not remain because it was protected by size or age. It remained because conditions aligned just long enough to allow return. Its presence today reflects chance layered atop physics, timing layered atop motion. Nothing about this makes the sea less real. It makes it more meaningful. Earth does not preserve in the way memory does. It does not hold on to things simply because they have existed before. It replaces, it rearranges, it moves forward without attachment to previous forms. Landscapes are not kept, they are revised. Mountains erode into plains, plains flood into seas, seas retreat into salt and stone. What replaces them may resemble what came before, or it may not. Similarity is not continuity. Recovery is not restoration. The Mediterranean returned, but it did not return unchanged. Its ecosystems rebuilt differently, its basins settled into a new shape, its chemistry stabilized under new constraints. What came back was familiar enough to feel continuous, yet altered enough to reveal the interruption beneath. This is how Earth works. It carries memory in structure, not in loyalty. What exists now is the result of what survived, not what was lost. Countless possibilities never reappeared. Entire ecosystems vanished quietly. Landscapes that once felt inevitable ended without ceremony. The planet moved on. The Mediterranean stands as a rare example of near erasure followed by recovery. That recovery can feel reassuring, but it should not be mistaken for a rule. Many systems do not return once they cross certain thresholds. Many seas that disappeared stayed gone. Earth does not promise reversibility. This understanding does not darken the present, it deepens it. To know that something exists without guarantee is to see it more clearly. The Mediterranean's calm becomes richer when understood as a moment held in balance rather than a permanent fixture. Its waves do not need to be feared to be respected. They carry a history of absence and return, written into salt beneath water and valleys beneath sediment. The sea breathes quietly today, but it has learned how close breath can come to stopping. This story reaches beyond one basin. It speaks to how the planet behaves everywhere. Stability is always conditional. Calm surfaces often hide layered histories of change. The Earth we inhabit now is one version among many that could have existed. What exists now is not what must exist forever. That thought does not ask for urgency or alarm. It asks for humility. It invites attention. It encourages a slower way of seeing, one that recognizes continuity as something earned moment by moment rather than assumed. The Mediterranean does not ask to be watched anxiously. It asks to be understood honestly, as a sea shaped by disappearance and return, as a system that survived through alignment rather than destiny. As night settles over its surface, the water reflects the sky with practiced calm. Nothing about the scene suggests fragility, and yet, beneath that calm lies a record that tells the truth gently. Earth replaces what it cannot preserve. It experiments. It allows failure. It permits recovery when conditions allow it and moves on when they do not. The Mediterranean remains not as a promise, but as a reminder that balance matters, that silence can carry history, that what surrounds us now is precious not because it is permanent, but because it exists at all. And in that quiet understanding, the story comes to rest, not with certainty, but with awareness.